Hi guys, today we're going to be looking at a question on work, energy and power. An object of mass 1.8 kg slides down a rough curved track and passes point A, which is 1.5 meters above the ground, at a speed of 0.95 meters per second. The object reaches point B at the bottom of the track at a speed of 4 meters per second. Question 5.1. Define the term conservative force. A conservative force is when the work done in moving an object between 2 points is independent of the path taken. Question 5.2. Name the conservative force acting on the object. So, as we can see, the object is sliding down the curved track, and the conservative force that acts on it would be gravity, as that's what's pulling it down the track. Question 5.3. Is mechanical energy conserved as the object slides from point A to point B? Choose from yes or no, give a reason for your answer. As they say in the question, it is a rough curved track. Therefore, mechanical energy is not conserved as there is a friction force present. Question 5.4. Calculate the gravitational potential energy of the object when it is at point A. So, at point A, we want to calculate the potential energy of gravity. Therefore, we can use the equation potential energy is equal to mass times gravity times height. We can then say we have our mass 1.8, we have gravity of 9.8, and we have the height of 1.5 meters. And if we plug all of that into the calculator, we should get 26,46 joules. Question 5.5. Using energy principles, calculate the work done by friction on the object as it slides from point A to point B. So as we know, friction is a non-conservative force. Therefore, we can say that the work of the non-conservative force is equal to change in kinetic energy plus the change in potential energy. We then can say, break down kinetic energy as half mass times velocity, or change in velocity. Therefore, half mass being 1.8, and the change in velocity being the final velocity squared, minus the initial velocity squared. And this is plus the change in potential energy, which is the final being 0 as it is on the ground and there's no height, minus the value we just calculated, which is 26,46. And if we plug all of that into the calculator, we get negative 12,87 joules. And that's the work done by friction. Surface BC in the diagram above is frictionless. Question 5.6. What is the value of the net work done on the object as it slides from point B to point C? From point B to point C, gravity is no longer acting on the object. Therefore, the only force that, well, it's not actually a force, it's momentum that the object has gained from sliding down the curve that causes it to move from point B to point C. There's no net force actually acting on it. Therefore, the work done is equal to 0 joules. And that's all for this video. Thank you.